In this video, we're going to continue, of course, to talk about factoring, but now we have finished talking about factoring 4 terms using grouping, 3 terms, trinomials, by either using trial and error, the reverse of FOIL, or recognizing that we're dealing with a perfect square trinomial and writing them as a binomial squared. And now we're going to head down the path for binomials. We're going to have 3 different kinds, so there are going to be several videos that you'll be seeing. The first one is a kind of binomial called the difference of 2 squares. Difference meaning subtraction. This only works for subtraction of a perfect square minus a perfect square. So let's go to our lesson. And before we get going, I want to remind you of the perfect squares. Whoops. Not going to redraw the list, but I am having a little trouble. There we go. But in our last video, remember that 1 squared is 1, 2 squared is 4, 3 squared, 9, ... So you can go back to the previous video and simply make yourself a list of the perfect squares 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and so on. That's all the way from 1 squared to 15 squared. So it'd be very good to remember those numbers, be familiar with them, that those are perfect squares. We also need to review something called a sum and difference product. Do you remember from, it would have been back in probably mod 6, that if you had x plus 3 times x minus 3, that something happens. The product of the first is x squared. The outer product is negative 3x. The inner product is positive 3x. Those cancel. Then the product of the last, it's a positive times a negative, so it's negative 9. If you had 5x minus 4 times 5x plus 4, the product of the first is 25x squared. The outer product is positive 20x. The inner product is negative 20x, so they cancel. The product of the last is a negative times a positive. It is negative 16. What you get when you multiply a sum and difference product, 1 plus, 1 minus of the same quantities, what you get is the difference of squares. So when you have a binomial that is the difference of squares and you're factoring it, it will always be 1 plus and 1 minus the square roots. So let's start with the first one. I'm going to enlarge these just a little bit. All right, factor the following binomial completely. All right, x squared minus 9. The first question is there a common factor, a GCF? No. Second thing, how many terms are there? Because if there are 4, we do grouping. If there are 3, trial and error, or maybe it's a perfect square. 2, there's more than one type, but this lesson, is it the difference, meaning is it subtraction, perfect square minus perfect square? Since the answer is yes, it factors into the sum and the difference of their square roots. The square root of x squared is x. The square root of 9 is 3. You can check it with FOIL. X times x is x squared. Outer is negative 3x. Inner is positive 3x, so those cancel. Positive 3 times negative 3 is negative 9. So these are our factors. All right, number 2. I have 25x squared minus 1. Is there a common factor? No. How many terms are there? 2. It's a binomial. Is it the difference of a perfect square minus a perfect square? The answer is yes. When that answer is yes, my factors, 1 plus, 1 minus, square roots. Square root of 25x squared is 5x. The square root of 1 is 1. And you can check it. Number 3. I have 9x squared minus 4. Is there a common factor? No. It's a binomial. Is it the difference of a square minus a square? Yes. So will be 1 plus, 1 minus. Square root of 9x squared is 3x. The square root of 4 is 2. Remember, you can check it with FOIL. Number 4. I have 4x squared plus 9. Is there a common factor? The answer is no. Is it the difference? Whoa. This is a sum, not a difference. That means it's prime. The sum of squares is prime. You need to be aware. When that is a plus, not a minus, and these are squares, it's prime. No factors that will work. All right, the next one. This is kind of a challenging problem. Several things about it stand out. First of all, they're really big numbers, and there's a m to the 4th. So let's see how that affects things. All right, I have 256 m to the 4th minus 625. Yes, this is a challenging question. First thing, is there a common factor? Well, you can work with these numbers a little bit, but 256 is actually made up of prime factors that all are 2's. It's 2 times 2 times 2 and so on. 625 is made up of prime factors that are all 5's. There's no common factor. All right, it's a binomial. Is 256 a perfect square? Depending on the calculator that you had, you'll either hit the square root key and then put in the 256 and out will pop 16, or you'll put in the 256 and then hit the square root key and you'll get 16. So it depends on your calculator, the order that you put things in. The square root of 625 is 25. These are perfect squares. Is m to the 4th a perfect square? It's a perfect square if something times itself gives you m to the 4th. And the answer is yes, m to the 2nd. So this is the difference. This is a perfect square. This is a perfect square. That means 1 plus, 1 minus. The square root of 256 is 16. What times itself gives you m to the 4th? M to the 2nd and 16 m to the 2nd. 16 times 16 is 256. M to the 2nd times m to the 2nd, you add the exponents for m to the 4th. The square root of 625 is 25. Now, this problem, because it started as m to the 4th, its factors have m to the 2nd. Now this one has a plus. Remember, this factor is finished. No more factoring. This factor has a minus. This is the difference of a square, 16m squared, minus 25. This can be factored even further. 1 plus, 1 minus, that's 4m plus 5 and 4m minus 5. This factor needs to be included. It can't be factored any further, but it is a factor. Can you still go further? The answer is no, because m is no longer m squared. So even though 4 is a perfect square, the m is not, neither is the 5. This is not the difference of squares. It's a difference, but it's not the difference of squares. Your answer is all three of those. Okay, this one is kind of challenging. Don't expect to see it on your test. It may or may not be in your homework assignment. Okay, difference of squares.